All right, ladies and gentlemen, for this particular lesson, what I wanted to do is I wanted to graph the Le Chatelier shift. So we talked about Le Chatelier shifts back when we did, let's see here, we talked about temperature, we talked about pressure, okay, and we talked about concentration. So how does that look graphically? All right, and so that's what we're going to do today. So what I have here is I'm going to give you a couple of examples. So example number one is I'm just going to say, just get a simple equation. So I have two reactants is in equilibrium with one product. Okay? Now, so what we have here is we have a graph, and what I'm going to do here on the y-axis is this: I'm going to go 0, 1, 2, 3, 4, 5. Okay? That represents the concentration. And then I'm just going to go like A, B, and so on across the top just to tell you the different stresses. So what I'm going to do is I'm just going to use a couple of lines. So here, in using the orange line, I will say that this is my reactant. So I'll just label it R. And here on the bottom, I'll use blue. Oh no, I'll use red. Here, I will say this is my product. Now, some of you might say, well, Mr. Chan, why did you choose reactant to put on the 3 concentration while red is in the products is in the 1 concentration? Because I felt like it. There is no rhyme or reason why I chose putting reactants on the top and products on the bottom. It's just, I just chose it like that. But the key thing is you should notice that the concentrations are constant, okay? So that is a symbol of equilibrium. That's characteristic of equilibrium. So let's say, for example, for A, okay, at situation A, let's say I increase the concentration of my reactant. That is my stress, okay? So if that is my stress, what I'm going to ask you to do is, what is the shift? So you remember from last day, if I increase my reactants, it'll shift to the products or shift to the right. And what will happen is the concentration of products will increase. Okay, so how will it look graphically? So what I'm going to do is I'm going to increase my reactant concentration. Okay, I'm just going to draw a line like this. Now, again, you might say, Mr. Chan, why did it go up 2 squares? Again, the answer is, I felt like it. Okay, so as it's shifting, it shifts to the product, shift to the right. My products is increasing, and what happens is my reactants will be decreasing. So how would it look graphically? So here, what I will do is, I'll draw it down. So my reactants go down, and my products will go up. Now, in this particular case, you notice that my reactants went down by a full square. My product went up by half a square. Now, you might say, well, Mr. Chan, why did the reactants go down by a full square? Again, for me, I felt like it. But why did my product go up half a square is if I put this down, is one thing you need to do is you need to follow the mole ratio when shifting. So because the mole ratio was 2 to 1, 2 reactants for every 1 product, what happens is you need to follow the mole ratio when shifting or when we are changing the concentration. To reestablish equilibrium. To reestablish equilibrium. Okay? Now, the other thing is, you should notice here, I'm going to put this in green. Notice, in this particular case, the new concentration at equilibrium is greater than the old concentration at equilibrium. The reason being is this. Even though you're shifting and you're making more products, remember, not all of the concentrations of the new concentration is used up. Some of it will be left over. Okay? So some of it will be left over. So something for you to be aware of. Okay? Now, also, please make sure you need to think about how this affects the rate. So going back to this particular scenario, what happens is if you when equilibrium is reestablished, because the new concentration is greater than the old concentration, the new rate at equilibrium is greater than the old rate at equilibrium. So please be aware of that. Okay? Now, I didn't have enough space here, but let's say scenario B, let's say I decrease my products. Okay, so let's say scenario B, I decrease my product. So scenario B, I decrease my concentration of product. What will happen is that it will shift left or shift to the product or shift right, sorry, and concentration of products will increase. Now, if we look at how that will work, so if my products went down, okay, so what will happen is my products will increase, okay, let's say an increase, okay, and then my reactants will decrease. Okay, now notice again, for my products, what happened here is, notice my products did not go back to the original concentration. Notice what happened here. Okay, so please be aware of that. All right, now, so this is typical of changing the concentration of reactants or products. You usually get one peak. Okay, now, let me give you a second example. So let's say, for example, here we have, let me do our classic one. We have 2H2 gas plus O2 gas would be equilibrium with 2H2O gas and energy. Okay? Again, if we set up our concentration here, we have 0, 1, 2, 3, 4, 5. Now, let's say, let's put the colors in here. So let's put one red up here. Let's put one green here. And let's put one, let's do, what's that one? Brown, I think. Yeah, brown here. Okay. Now, again, let's have scenario A, B, and C. So we have A, B, and C. So let's say this would be, let me see how I'm going to make this fun. So let's say this is my H2O. Let's say this is, let's see here. This is my O2. And this one down here is my H2. Okay. Now, let's say, for example, let's increase for A. Let's say we increase my concentration of O2. Okay. Now, again, you know that if I increase my O2, that's a reactant. So it is shift to the products. And therefore, you have an increased concentration of H2O. So how would it look? So in this case, let's say I do O2. Let's say I go, let's bring it up here, okay? Now, so it'll shift to the products. So that means my oxygen will go down. Okay, so let's say it'll go down this much. Okay, my water will go up this much. And my hydrogen will go down a lot. Now, one thing, let's say almost go down to 0. Okay. Now, notice hydrogen also went down. The reason being is because hydrogen is a reactant. So as the products are going up, since I'm producing more water, both the oxygen and the hydrogen, since they are both reactants, will respond in the same way. So as the equilibrium is being reestablished, the product concentration is going up, the reactant concentration is going down. Okay? All right, let's do another one. So in this case, for scenario B, let's do it this way. So let's say if scenario B, okay? Let's say we increase the pressure. Now, you remember increasing the pressure or decrease the volume favors the side with fewer particles. So again, what will happen here is we will shift to the products, okay? And what we get is an increased concentration of products. Now, how will situation B look? I'm just going to move this here. So situation B. So if we increase the pressure, one thing you will notice is that all the concentration goes up. All the concentrations go up. Okay? Now, why do all the concentrations go up? Is because when you squeeze a vessel, when you squeeze a container, you cannot isolate just the container or just the products or just the reactants. And so as a result, what happens is all of the concentrations will either go up or either go down, depending if you had increased the pressure or decreased the pressure. Okay, so in this case, because I increase the product, it will go up. Sorry, my graph didn't look too good. And here, this will go down by a little bit because equilibrium is establishing. And here, hydrogen will go down, again, following the mole ratio. But I didn't do very good on this graph. That's okay. 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 All right. Now, the last one, let's say C, is let's do a temperature change. Let's say if we increase the temperature. Now, if you increase the temperature, remember the temperature favors the endothermic reaction. So in this case, the endothermic reaction is going from products to reactants. So you could say it shifts to the reactants. If you're not too sure why, please make sure to look at last day's notes. And so what happens is if it's shifting towards the reactants, the concentration of reactants will increase. Again, it'll increase by mole ratio, which I will try to achieve. So when you increase the temperature, how does it look? In this particular case, there is no peak. So here, we would go up. Let's say it goes up half. Okay. Hydrogen will also go up since it's a reactant, and let's say it'll go up a little bit more. And here, the water will go down. Okay, let's say, okay. Now again, I don't know if it represents it very well. It follows the mole ratio. Okay. Now, but you should notice the difference between A, B, and C. Notice how to indicate the difference between a change in concentration, change in pressure, and change in temperature. When you have a change in concentration, there's only one peak, either in the reactants or the products. For a change in pressure, whether up or down, it affects both the reactants and the products. So what you see is a change in the concentration for all the reactants and the products. For a change in temperature, notice there is no peak. It's actually a gradual change, which makes sense. Because let's say you are baking, you have to preheat an oven to, let's say, 400 degrees Celsius. When you turn on the oven, it takes time for the oven to heat up. It does not become instantaneously 400 degrees Celsius. Okay? So that's why if you have a change in temperature, you do not have any peak in or significant change in concentration like in scenario A or scenario B. Now, in this case, in all three scenarios, I've just focused on concentration. One thing you should be aware of, in the back of your mind, how is rate affected? In all the scenarios. Okay? So you should always be thinking about what's happening to the rate. What's going on? For C, when I increase the temperature, yes, there's a shift in reactants, okay? But you should be aware that both the forward and the reverse rate increase. It's just that the reverse rate increases more. All right, ladies and gentlemen, so that is the graphing Le Chatelier shifts. All right, thank you very much. Have a good day.